A soccer ball has 32 faces. 12 of them are regular pentagons and 20 of them are regular hexagons. The surface area in square units of a soccer ball with edge length 2 can be expressed in simplified form as a squared of b plus the quantity c root d plus e square root of the quantity f plus g root h, where a, b, c, d, e, f, g, and h are integers, and b, d, h in the greatest common divisor of f and g do not have any perfect square divisors greater than 1. Find a plus b plus 2c plus d plus e plus f plus 3g plus h. And it turns out that this 2 and this 3 turn out to be important because in the end, there are many ways to express the surface area, and the 2c and the 3g ensure that this sum is equal no matter what those forms are. Okay, so let's start out by thinking about what it means to have the surface area. So the surface area of the soccer ball is the total combined area of all of the faces. And since all of the regular pentagons are congruent and all the regular hexagons are congruent, we can just find the area of a regular pentagon and the area of a regular hexagon and multiply them by 12 and 20 respectively to account for all of the faces. Okay, so let's start out by finding the area of the hexagon because that's simpler. So we know that this hexagon face has edge length 2, and this is because we're given the soccer ball has edge length 2, which means that each of the edges of each of its faces is 2, right? And what we can do in this case is actually break it up into 6 equilateral triangles. Each of them is going to have side length 2, and each of them is going to have 60-degree angles, right? And we can find the area of one of these regular, should I say equilateral triangles by dropping this altitude down to the side. And this altitude actually breaks the side into 2 equal pieces. Each of them has length 1, and since this has length 2, our height is square root of 3 because by Pythagorean theorem, 1 squared plus square root of 3 squared is 2 squared. So the base of this triangle is 2 and the height is square root of 3, so our area of one triangle is half times base times height, which is equal to square root of 3. So the area of all 6 of these triangles is going to be 6 square root of 3. But since we have 20 faces, 20 hexagon faces, we have to multiply this by 20 because each of the 20 hexagon faces has this area, and we have to count for all of them, so we just multiply by 20. And we get that 120 root 3 is the total area of all the hexagons. So right, total area of hexagons. Okay, so that was the easy part. Let's move on to the harder stuff, namely finding the area of a regular pentagon. And first of all, let me draw a diagram to show you what we're dealing with. We have a regular pentagon over here, and we can't divide it up into equilateral triangles like we did with the hexagon. So instead, we have to be creative. So what I do is I draw each of these line segments connecting the center of this regular pentagon to each of the vertices. And now let me drop this altitude from the center to one of the sides. Okay. Well, first of all, since all of these angles, 1, 2, 3, 4, 5 are equal to each other, they have to sum up to 360. Each of them is going to have a measure of 72, right? Each of these angles is going to have a measure of 72. And since this height splits this angle into 2 36-degree angles because by symmetry, this is equal to that. And this isosceles triangle, we already know an altitude is also a median in this case, and it's also an angle bisector because each of these angles is 54, right? Because this angle is 108. So each of these 2 angles is 36 degrees, and this side length, both of these are 1, and we're going to call this height h. We actually have a name for this length. It's called the apothem. And what we have is using, remember, SOHCAHTOA, tangent of 36 is equal to opposite side divided by adjacent side, 1 over h. And you might recall it also equals to sine of 36 over cosine of 36. So it remains to find what sine and cosine of 36 are. And we can do this by looking at this particular isosceles trapezoid. And this isosceles trapezoid has angles 72, 108, 108, 72. And you can notice that if you tack this triangle on, then you get your regular pentagon because this side, and this side, we can define to be all equal to each other. So we define it so that if you tack this triangle on, you get a regular pentagon, right? And we're going to assume without loss of generality that each of these sides has length 1, right? And okay, next thing I'm going to do is I'm going to draw this diagonal, and both of them are going to be equal to this side. We're going to call them x. The reason is because all of them are diagonals of this regular pentagon, so all of them would have the same length, right? And we're going to use Ptolemy's theorem. And what that states is if you have a cyclic quadrilateral, cyclic meaning it can be inscribed in a circle, and it has 4 sides and 2 diagonals, and the sides have lengths A, B, C, D in this order, and the diagonals have length E and F in any order. Then Ptolemy's theorem states that AC plus BD is equal to EF. Why is this useful? Because since this angle is 72, this angle is 108, these triangles sum up to 180, and that's the criteria for a cyclic quadrilateral. Therefore, Ptolemy's theorem states that x times 1 plus 1 times 1 is equal to x times x, equal to x squared. So x squared minus x minus 1 is equal to 0. So we can find what x is. And x turns out to be equal to 1 plus root 5 over 2 using the quadratic formula. And now at this point you might be stuck, but take a look at this dotted triangle up here, which has like side length 1. And if you drop this altitude over here, because this is also length 1, splits this into x over 2 and this side into x over 2 and x over 2. And this angle is a 36-degree angle, right? Because these triangles sum up to 108, which is the angle of a regular pentagon. So this angle is 36. So cosine of 36 is equal to adjacent length divided by hypotenuse, which is x over 2 divided by 1. And you can just divide x by 2, you get square root of 5 plus 1 over 4. Great, so we have what cosine of 36 is. So let me clear all of this stuff because you have to do a lot more. And what you can do now is you can say, okay, we have cosine of 36. Now let's use that to find sine of 36. And we can do that by using the identity sine squared of 36 plus cosine squared of 36 is equal to 1. All right, so sine squared of 36 plus this thing squared, which you can compute as 6 plus 2 root 5 over 16 is equal to 1. So sine squared of 36 is equal to 10 minus 2 root 5 over 16. And you can take the positive square root of both sides, and sine of 36 is in the first quadrant. This is equal to root 10 minus 2 root 5 over 4. So sine of 36 over cosine of 36 is this divided by this, which is equal to square root of 10 minus 2 root 5 over root 5 plus 1. Right? So this is equal to 1 over h, and therefore h is equal to root 5 plus 1 over square root of 10 minus 2 root 5. And why does this help us? Because the area of this triangle is half times the base, which is 2, this base, times the height. So this triangle has area H. So 5 of these congruent triangles have area 5H. So the area of one of these regular pentagons is 5H. So the area of 12 of these regular pentagons is 12 times 5H, which is 60H. So we just need to calculate 60H and add that on to 120 root 3. We got our total surface area. So now let's go ahead and try to simplify this to make it have a nice rational denominator by multiplying the numerator and the denominator by 10 plus 2 root 5. And what you get is on the numerator, you have our root 5 plus 1 square root of 10 minus 2 root 5, 10 plus 2 root 5, excuse me. On the denominator, you get a nice simple square root of 80. When you multiply these two out. And you can just multiply the numerator, the denominator by root 5 to get root 5 plus 1 times root 5 is 5 plus root 5. So we multiplied the numerator, the denominator by root 5, and we get 5 plus root 5 over 20. Okay, so this is equal to h. So 60h is this times 60, which is 3 root 5 plus 15 square root of 10 plus 2 root 5. So our total surface area is this stuff plus 120 root 3. And therefore, our a plus b plus 2c plus d plus e plus f plus 3g plus h is going to be equal to 120 plus 3 plus 2 times 3 plus 5 plus 15 plus 10 plus 2 times 3 plus 5, which is equal to 170 if you go ahead and do all of these calculations. So our answer is D. So thanks for watching, and I will see you next time.